According to the National Electrical Code, specifically Article 408.23a, service equipment can be installed either indoors or outdoors. If you choose an outdoor installation, the service equipment must be accessible and protected from weather conditions that could compromise its safe operation. When connecting the main disconnect to the breaker panel, the conductors must be installed within a conduit or another approved enclosure. The conduit plays a crucial role in protecting the conductors. The conduit needs to be appropriately sized for the conductors you're using. Ensure it's installed according to the NEC guidelines. When creating a hole through the wall for the conduit, it's important to properly seal it. This sealing prevents moisture and pests from entering the breaker panel, which could lead to damage or safety hazards. Proper support for the conduit is essential. The conduit should be securely supported throughout its entire run, both inside and outside the building. This support prevents sagging or damage to the conduit and conductors. The conductors used to connect the main disconnect to the breaker panel must be rated for the voltage and current they will carry. This rating ensures that the conductors can handle the electrical load without overheating or causing a fire hazard. All electrical work should be performed by a qualified electrician. Their expertise ensures the job is done safely and in compliance with all applicable codes and standards. Once the installation is complete, the entire system should be inspected by the local building inspector. This inspection verifies that the installation meets all code requirements and safety standards. Proper bonding and grounding of the service equipment are crucial for safety. This bonding and grounding provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock. The breaker panel should be placed in a readily accessible location within the building. This accessibility allows for easy maintenance and quick access in case of emergencies. The main disconnect must be easily accessible for maintenance and emergency shutoff. This accessibility ensures that the power can be quickly and safely shut off if needed. Ensure proper ventilation for the breaker panel to prevent overheating. Overheating can damage the breakers and other components, leading to malfunctions or even fire. The main disconnect and breakers must be coordinated to provide proper protection for the load. This coordination ensures that the breakers will trip in the correct sequence, preventing damage to the equipment and conductors. By following these guidelines carefully, you can safely and effectively install an indoor breaker panel back-to-back with an outdoor main disconnect. Remember, safety is paramount and consulting with qualified professionals is always recommended. Consider the ambient temperature where the conductors are installed. Conductors have ampacity ratings that are based on specific temperature conditions. If the ambient temperature is higher than the rating, you may need to adjust the conductor size. Consider voltage drop. Over long distances, voltage drop can become a significant issue. Make sure to calculate the voltage drop to ensure that the voltage at the breaker panel is within acceptable limits. Consider future expansion. If you anticipate needing more power in the future, it's a good idea to install a larger conduit and conductors than you currently need. This will make it easier to add additional circuits later on. Check local codes and regulations. In addition to the NEC, there may be local codes and regulations that you need to comply with. Be sure to check with your local building department to ensure that your installation meets all requirements. Maintain detailed records. Keep detailed records of all work performed, including conductor sizes, conduit types, and inspection reports. These records will be helpful for future maintenance and troubleshooting. Consider using surge protection. Surge protection devices can help protect your electrical equipment from damage caused by voltage surges. It's a good idea to install surge protection at the main disconnect and at the breaker panel. Consider using arc fault circuit interrupters, or ASIs. ASIs are designed to protect against arc faults, which are a common cause of electrical fires. ASIs are required in many areas of the home, and it's a good idea to consider using them throughout your electrical system. Consider using ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against ground faults, which can cause electrical shock. GFCIs are required in wet locations, such as bathrooms and kitchens, and it's a good idea to consider using them throughout your electrical system. Make sure all electrical boxes are properly grounded. Grounding electrical boxes helps to prevent electrical shock. Use appropriate connectors for all wire connections. Using the correct connectors ensures a secure and reliable connection. Label all circuits clearly. Labeling circuits makes it easier to identify and troubleshoot problems in the future. Keep the breaker panel clean and free of debris. Dust and debris can accumulate in the breaker panel, which can cause overheating and other problems. Inspect the breaker panel regularly for any signs of damage or corrosion. Regular inspections can help to identify and prevent problems before they become serious. Test the breakers regularly to ensure that they are functioning properly. Testing the breakers ensures that they will trip when they are supposed to. Replace any breakers that are not functioning properly. Faulty breakers can be a safety hazard. Keep a supply of spare breakers on hand. Having spare breakers on hand will allow you to quickly replace a faulty breaker. Use a torque wrench to tighten all electrical connections. Using a torque wrench ensures that the connections are properly tightened, which helps to prevent overheating and other problems. Do not overload circuits. Overloading circuits can cause the breakers to trip and can also be a fire hazard. Use the correct size breaker for each circuit. Using the correct size breaker ensures that the circuit is properly protected. Do not use extension cords as a permanent wiring solution. Extension cords are not designed to be used as a permanent wiring solution. They can be a fire hazard. If you need additional outlets, have a qualified electrician install them. Do not attempt to repair electrical equipment unless you are qualified to do so. Electrical repairs can be dangerous. If you are not qualified to make electrical repairs, call a qualified electrician. Always disconnect the power before working on electrical equipment. Disconnecting the power helps to prevent electrical shock. Use caution when working around electricity. Electricity can be dangerous. Always use caution when working around electricity. Wear appropriate safety gear when working on electrical equipment. Safety gear can help to protect you from electrical shock and other injuries. Follow all safety precautions when working on electrical equipment. Following all safety precautions can help to prevent accidents. If you are not sure how to do something, ask a qualified electrician. It is better to be safe than sorry. Remember to prioritize safety when working with electricity. Electricity can be dangerous, so it is important to take all necessary precautions. Consider the short circuit current rating, also known as the SCCR, of the electrical panel. The available fault current at the service needs to be lower than the SCCR of the panel, or other measures need to be taken to increase the SCCR. The calculation of conductor ampacity is governed by NEC Article 310.15. This article provides requirements for ampacity based on insulation type, number of current carrying conductors, and ambient temperature. Article 310.16 provides tables for ampacity in specific conditions. When dealing with multiple conductors in a raceway or cable, adjustment factors from Table 310.15 cone must be applied. For example, if there are more than 3 current carrying conductors in a raceway, the ampacity of each conductor must be reduced. Directing factors are crucial when conductors are exposed to elevated temperatures. Article 310.15b provides guidelines on temperature correction factors. Higher ambient temperatures reduce the conductor ampacity and must be considered. Proper conductor sizing minimizes voltage drop. The NEC recommends limiting voltage drop to 3% for feeders and 5% overall. The formula for voltage drop is voltage drop equals 2 times K times A times D divided by Cm, where K is the constant for the conductor material, I is the current, D is the distance, and Cm is the circular males of the conductor. Grounding and bonding are critical for safety. Article 250 outlines the requirements for grounding and bonding electrical systems. Proper grounding provides a low impedance path for fault currents, minimizing shock hazards. Grounding electrode conductor sizing is detailed in Table 250.66. The size of the grounding electrode conductor depends on the size of the service entrance conductors. Bonding ensures that all metallic parts are at the same electrical potential. Article 250.92 covers bonding of service equipment. The bonding jumper should be sized according to Table 250.102 cone. Overcurrent protection is essential for preventing damage from overloads and short circuits. Article 240 covers overcurrent protection. Circuit breakers and fuses are the most common types of overcurrent protection devices. Circuit breakers are resettable, while fuses are single-use devices. The interrupting rating of overcurrent protection devices must be sufficient for the available fault current. Select the correct overcurrent protection device based on the conductor ampacity. The NEC provides guidance on the maximum overcurrent protection for conductors. Surge protection devices, or SPDs, protect electrical equipment from voltage surges. Article 285 covers SPD. SPD should be installed at the service entrance and at downstream panels. SPD diverts surge current to ground, preventing damage to sensitive electronics. Arc fault circuit interrupters, or FSIs, protect against arc faults, which can cause fires. Article 210.12 covers FSI protection. FSIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. FSIs detect arc faults and trip the circuit breaker. Ground fault circuit interrupters, or GFCIs, protect against ground faults, which can cause electrical shock. Article 210.8 covers GFCI protection. GFCIs are required in wet locations, such as bathrooms, kitchens, and outdoor receptacles. GFCIs detect ground faults and trip the circuit breaker. Proper wiring methods are crucial for safety and reliability. Chapter 3 of the NEC covers wiring methods. Common wiring methods include rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and non-metallic conduit, or PVC. Each wiring method has its own advantages and disadvantages. Select the appropriate wiring method based on the application. Electrical boxes provide a safe enclosure for electrical connections. Article 314 covers electrical boxes. Boxes must be sized appropriately for the number of conductors and devices they contain. Boxes must be securely mounted. Use appropriate connectors for all wire connections. Connectors must be rated for the conductor size and type. Use wire nuts, terminal blocks, or crimp connectors. Proper labeling is essential for safety and troubleshooting. Label all circuits clearly. Use permanent labels that are easy to read. Label the breaker panel, receptacles, and switches. Proper grounding ensures electrical safety and minimizes the risk of electrical shock. Grounding provides a low impedance path for fault current, allowing the overcurrent protection device to trip. The grounding electrode system consists of a grounding electrode, a grounding electrode conductor, and a bonding jumper. The grounding electrode can be a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode conductor connects the grounding electrode to the service equipment. The bonding jumper connects the service equipment to the neutral conductor. Bonding ensures that all metallic parts are at the same electrical potential, minimizing the risk of electrical shock. Bond all metallic enclosures, such as conduit, boxes, and equipment housings. Use bonding jumpers to connect metallic parts together. Proper overcurrent protection prevents damage from overloads and short circuits. Overcurrent protection devices include circuit breakers and fuses. Circuit breakers are resettable, while fuses are single-use devices. Select the correct overcurrent protection device based on the conductor ampacity and the equipment being protected. The interrupting rating of the overcurrent protection device must be sufficient for the available fault current. Regular inspection and maintenance are essential for ensuring the safety and reliability of the electrical system. Inspect the electrical system regularly for any signs of damage or deterioration. Test the overcurrent protection devices to ensure that they are functioning properly. Replace any damaged or deteriorated components. Keep the electrical system clean and free of debris. Proper documentation is essential for troubleshooting and future modifications. Maintain accurate records of all electrical work. Include wiring diagrams, panel schedules, and equipment specifications. Keep the documentation in a safe and accessible location. Always follow the NEC and local codes. Electrical codes are designed to protect people and property from electrical hazards. Stay up to date on the latest code requirements. Consult with a qualified electrician if you have any questions. The 2023 National Electrical Code is a comprehensive set of standards for safe electrical installations. It is updated every 3 years to reflect the latest technologies and best practices. Some key changes in the 2023 NEC include revisions to arc flash hazard warning requirements, updates to energy storage system requirements, and new requirements for electric vehicle charging equipment. Understanding these changes and staying current with NEC is essential for anyone involved in electrical work. Regarding the service entrance, the conductors that bring power from the utility to your building must be sized correctly to handle the load. The size of these conductors is determined by a load calculation, which takes into account all the electrical loads in the building. The service entrance conductors must be protected by an overcurrent protection device such as a circuit breaker or fuse. The size of the overcurrent protection device must be no larger than the ampacity of the service entrance conductors. The service equipment, which includes the service disconnect and the metering equipment, must be installed in a suitable location. The location must be accessible and protected from the weather. The service equipment must be properly grounded and bonded. The grounding and bonding system must comply with the requirements of Article 250 of the NEC. The building's electrical system must be properly coordinated. This means that the overcurrent protection devices must be sized and selected so that they will trip in the correct sequence, preventing damage to equipment and minimizing the extent of any power outages. Coordination studies are often required for large electrical systems. The installation must comply with all applicable codes and regulations. This includes the NEC, as well as any local codes and regulations. An electrical permit is typically required before any electrical work can be performed. An inspection is typically required after the electrical work is completed to ensure that it complies with the codes and regulations. Working with a qualified electrician ensures that the electrical installation is safe, reliable, and compliant with all applicable codes and regulations. The electrician can perform a load calculation, select the correct size conductors and overcurrent protection devices, install the service equipment in a suitable location, properly ground and bond the system, coordinate the electrical system, obtain the necessary permits, and arrange for an inspection. Remember that electricity is dangerous and must be treated with respect. Always follow safe work practices when working with electricity. If you are not qualified to perform electrical work, hire a qualified electrician.